Good morning, I'm Mr. Precella. I want to do a little bit more anti-differentiation with my Math 1325 class. We were working on homework number 15, and I have some examples that I wanted to do. I want to do numbers 6, 8, and 9 today. So I have recopied number 6. So here it is. I want us to evaluate this antiderivative. Let's see, I need something to... There it is. So sometimes we use U substitution, sometimes we don't. What do you think? Do we need a U substitution for this? No, because it's just a variable to a power. When you have a quantity, a function of x raised to a power, that's when you definitely want to try U substitution. But this is just variables to powers, variables to powers. So, remembering how we're anti-differentiating, I'll write my 12x. What's the new exponent? Okay, you add 1. 1 plus 3/4 is 7/4. And then we divide by 7/4. Minus, this minus right here is the minus I have right here. I have an 8x, new exponent, 10/3. Add 1, 7/3 plus 3/3 is 10/3. Divide by 10/3. And I still have that old plus c, my constant of integration. And what's our trick? We have compound fractions in the first two terms. So, okay, so here we'll multiply by the minor denominator of 4. That'll give me, well, the denominator reduces nicely to 7. 4 times 12, that's a 48. X to the 7/4 all over 7 minus here. Okay, but multiply by 3, okay. And so we have what? A all over 10. And I think we can cancel a common factor there. 48/7 we can't cancel a common factor. We're just stuck with that 48 x to the 7/4 over 7. But here we can cancel a common factor of 2, make that a 12x to the 10/3. All over 5 plus c. For my final answer, any questions there? You have to know when to use a U substitution and when not to. And number 8. Any questions on number 6 before we go on? Okay. Number 8. Let's see, push it up right there. For the following derivative, find the antiderivative that satisfies the given condition. The derivative is negative 7 over x squared, and we know that for the original function, when you plug in a 1, the function value is 15. So this is number 8, and I've written it larger here in my own big handwriting, so it's easier for you to see. They gave us the derivative. P prime is equal to negative 7 over x squared. They told us that when we plug 1 into the original function p, the function value is 15. Find the antiderivative that satisfies the given condition. Well, we're trying to find p. So p is equal to the original function p. What did we differentiate to get a negative 7 over x squared? So we want to anti-differentiate negative 7 over x squared in terms of x. We're going to have to rewrite this. How would we rewrite that negative 7 over x squared?
Move the x square up and make it negative.
Okay, so move the x squared up. make it negative. Do we need a u substitution? Yes? No? Okay, I've heard both. Which one? I don't think so. The only thing being raised to the power is just a single x. Once again, use a u substitution when you have a function of x, some quantity of x raised to a power. But if it's just a variable to a power, you should not need a u substitution. So we have a negative 7x, add 1, negative 1, divide by the new exponent negative 1, plus my constant c. This is working out nicer than I thought it was going to. Negative 7 divided by negative 1, that's just a positive 7x to the negative 1 plus c. Now let's rewrite that using a positive exponent. So we have the original function p is equal to 7 over x plus my constant c. And we have to find what that constant c is. That's where this condition here comes into play. P of 1 is equal to 15. That's saying when you plug 1 in for x, the value of the function is 15. So when x equals 1, the value of the function is 15. So I'm going to move this up. So plugging in 15 here, plug in 15 for p, we have a 7 over 1 plus c, so that says 15 is equal to 7 plus c. What's my constant of integration? 8. Subtract 7 from both sides to get c equals 8. So 8 is what we should have had there. So my final function, p is equal to 7 over x plus 8. Any questions there? It's just a variable to a power, so we didn't need a u substitution. Just add 1 and then divide by the new exponent. Then use the fact that p of 1 is equal to 15 to determine the constant. And here's the thing you'd have to type into my math lab. Any questions there? One more problem I want to do from this homework. Number 9. So number 9, let's find it. Where is it? The rate of growth of the population N of t of a new city, t years after its incorporation, is estimated to be, here's the derivative, the rate of growth of the population. The derivative of n with respect to t is equal to 600 plus 300 square roots of t, where t is between 0 and 4. So this rate of change is only working for years 0 through 4. If the population was 1,000 at the time of incorporation, find the population 4 years later. So we're wanting to determine the population. They gave us the rate of change in the population. So they gave us the derivative, but they want us to determine the population. So we're going to have to go backwards. Okay. So there, let me move this down some, right there. So there's the derivative they gave us. They want us to go backwards and find the population. This is the rate of change of the population. So to determine the population, and they're using an n for probably it's used for number of people in the city. That N is probably standing for number. So they want us to anti-differentiate 600 plus, how am I going to have to rewrite that 300 square roots of t? So 300t to the 1/2. We're going to anti-differentiate in terms of t. Oh, that blue doesn't show very good, does it? This is a sum of terms. Do I need to use substitution? No, it's just a sum of terms. The only thing being raised to a power is a single letter, so I agree we don't need to use substitution. The antiderivative of 600 in terms of t is 600t plus, it's a 300t to the 1/2 plus 1 is 3/2. Divide by 3/2. And we still have plus c, my constant. So we can clean this up a little bit. I would multiply above and below by what here? 2. So we have a 600t. So the number of people in the city is equal to 600t plus, that's a 600t divided by 3. I think I can write that as just a 200t to the 3/2 plus my constant c. The 2's in the major denominator canceled out, leaving us 600 divided by 3, which gave me 200. And ultimately they want us to determine the population in 4 years, but we can't determine the population just by plugging in a 4 then, because we still have that c that we don't know. Let's look back at the problem. Looking back at the problem we have, I think they've given us a piece of information, a specific instance. If the population was 1,000 at the time of the city's incorporation, so the population was 1,000 at the time the city was created, and t is the number of years after its incorporation, what is that sentence they're saying? If the population was 1,000 at the time of incorporation, what's the t value?
0.
When t is equal to 0, how many people are in the city? 1,000. So we can plug in 0 for t and 1,000 for n. So let t equal 0 and n equal 1,000. So we have plugging in 1,000 here. Oh, those zeros are nice there. We're going to have 1,000 equals 600 times 0 plus 200 times 0 to the 3/2 plus c. What are these terms going to equal? 0. 600 times 0 is 0. 0 to the 3/2 is 0 times 200 is 0. So really, what is my constant? 1,000. So I now know my population function. The number of people in this city, the number of people is 600t plus 200t to the 3/2 plus that 1,000. That 1,000 we're plugging in now for our constant of integration. I forgot what they asked. What do they ask us to find? Okay. Find the population 4 years later. Here's what they want us to find. The population 4 years later, so that means t is equal to 4. Plug in 4. When t equals 4, the number of people in this city, 600 times 4 plus 200 times 4 to the 3/2 plus 1,000. Let's see, 4 to the 3/2, that's the square root of 4, which is 2. 2 cubed is 8. 8 times 200, that's 1,600. Those of you punching that into your calculator, see if we get the same answer. 4 times 600 is 2,400 plus a 1,000. 2,400 plus 1,600, that's 4,400. No, pardon me, that's 4,000 plus 1,000, I'm getting 5,000. So in 4 years' time, this city has grown from 1,000 people to a population of 4,000. Any questions there? So they gave us the rate of change of population. We had to anti-differentiate. We didn't need a U substitution because we didn't have quantity squared. We then used the fact that at time 0, the number of people in this city was 1,000. We used that to determine the constant. We replaced the C with the value of the constant. Then they wanted to know what was the population 4 years later, so we plugged in 4, and that gave us a population of 5,000 people. Any questions? Okay, well, I think I'm through discussing anti-differentiation today, and I'm going to take a break. Bye-bye.